What we're looking at today is a between subjects factorial ANOVA. Now, if you remember back to previous lectures or courses, that you may recall that when you tested participants once and we're wanting to compare across two levels of an independent variable, then we're using an independent samples t-test. When participants are tested once and we're looking at one independent variable with more than two levels, so 3 or more levels, then we're in ANOVA territory. And you may recall that you did a one-way between subjects ANOVA. If we have one independent variable with 3 levels or more, then this is known as a one-way ANOVA because it has only one independent variable. But as soon as we're talking about participants being tested only once, and we're looking at the means of groups that vary across more than two or more independent variables, then we're moving into a between subjects factorial ANOVA. What I'm hoping you're going to get from today's lecture is an understanding of the purpose of a between subjects factorial ANOVA. Also conceptually understand what the main effect in a factorial ANOVA is, and be able to also identify this in the SPSS output. So be able to understand the SPSS output that a between subjects factorial ANOVA gives you. Also understand conceptually what the interaction effect means in a factorial ANOVA, and be able to identify this in SPSS output and the rationale for using simple effects in terms of analysing the interaction effects. And also what I want to do is touch on family-wise error in today's lecture. So what an ANOVA is doing is looking at the difference between groups on one independent variable with more than two groups or levels. For example, you might be interested in whether the amount of exercise alters people's levels of well-being. Participants might be grouped into no exercise, moderate exercise, and regular exercise. So because this is one independent variable with 3 levels, I've got to get my fingers right there, one independent variable with 3 levels, so more than 2 levels, it's a one-way between subjects ANOVA. So in a one-way ANOVA, we're actually comparing the average well-being for each of the 3 groups. But let's suppose that psychological well-being, the research is led to believe is related to particular levels of exercise and also to a second factor that might affect well-being, the personality variable, the personality of the individual. Say we measure the personality on type A or type B type personality. Now the prediction might be that the competitive element of type A personality would interact with exercise and have an effect on well-being in a way that type B would not. Or stated more simply, the effects of exercise on well-being would vary according to personality type. All of a sudden we've moved to the simplest between subjects factorial ANOVA, a two-way factorial ANOVA in which 2 independent variables are being looked at. This is referred to as an A times B design, factor A with factor B. In this case, factor A, or independent variable A, so factor and independent variable mean the same thing, factor A has 3 levels of exercise and factor B, personality, has 2 levels. This is known as a 3 by 2 factorial ANOVA. Now in factorial designs, the factor is the independent variable. In this example, we have 2 factors, amount of exercise and personality. A level is a subdivision of the factor. In this example, the amount of exercise has 3 levels and personality has 2 levels. Sometimes we depict a factorial design with a numbering notation. In this example, we can say that we have a 3 by 2 or 3 times 2 factorial design. In this notation, the number of numbers tells you how many factors there are, and the number of values tell you what the levels are, or how many levels there are. Another example we might be interested in, if we were a psychologist, is whether the type of reward increases people's motivation to study. Participants might be grouped as no reward, informational reward, or concrete reward. This would be an example of a one-way between groups ANOVA, in which we're looking at one independent variable which is type of reward, which has 3 levels. And the dependent variable might be some measure of motivation to study. So the one-way ANOVA would compare the average motivation scores for each of the 3 groups, or each of the 3 levels. But let's suppose we're led to believe or led to suspect a second factor might affect motivation to study, and that might be difficulty of the course. The effects of type of reward on motivation may vary according to the difficulty of the course. All of a sudden we've moved to the simplest factorial ANOVA, which is a two-way between subjects ANOVA in which 2 IVs, or independent variables, are being looked at. In this case, factor A has 3 levels of reward and factor B has 2 levels of difficulty. This is known again as a 3x2 factorial ANOVA. A 3-way factorial ANOVA is with 3 independent variables and is referred to as a by B by C design. And of course you can have more and more factors, but obviously the more variables or the more independent variables you have in your model, the more complex the model becomes and the interpretation of that model becomes. Now it just so happens that when we conduct a factorial ANOVA, we're interested in a few things. Firstly, main effects, and this describes the impact of each factor or independent variable on its own. So take the relationship of exercise and personality on the well-being example I talked about earlier. If you remember, this is a 3x2 factorial ANOVA in which exercise had 3 levels, which no exercise, moderate exercise, and lots of exercise or regular exercise, and personality had 2 levels, type A personality and type B personality. In this case, there are 2 factors, exercise and personality. The dependent variable is well-being. And because there's 2 factors, it means there's also 2 main effects. The main effect for exercise, in other words, let's assume I've not measured personality or I lump personality all in together, and I just want to know the relationship of exercise on well-being. Then there's a main effect of personality. So in other words, let's assume I've not measured how much exercise you do, or I just collapse on the levels of exercise, and I just want to know the relationship between personality and well-being. Interaction effects. Now this is the extent to which differences in the levels of one factor are the same at each level of the other factor. So is the relationship between exercise and well-being modified by personality type? Or vice versa, is the relationship between personality and well-being modified by the amount of exercise that you do? Let's have a look at an example to illustrate these points in a bit more detail.